up with some closing remarks related to collecting, outputting, and importing data from datasets. I tried to give you a hands-on view of how you can collect data with entity logic and output data in a variety of forms. We saw the capacity to output it to particular text files, to Excel. There are a couple additional avenues I wanted to talk about very briefly, and I want to talk about some principles as well. It's very important that when you store data, you store metadata as well, not just data related to the model's operation, but information such as the model version, the model that was used to create it, and any assumptions. So in the form of, say, parameter values, like Priesri is automatically recording with her tool. You may also want to record things like the random number seed, etc. The point is to be able to get it to the point of recreatability. And metadata beyond data is critical for making sense of the data that you see. All the data in the world will just be columns of numbers unless there's context given to it. Provenance information, where it came from, what assumptions were used in producing it. If you haven't documented, the model that was used to create it, the particular version of the model, it's going to lose a lot of value very quickly. Okay. We talked about a variety of ways of sort of exporting different types of data. I tried to rehearse them because they're very familiar. We've also seen in the course of this boot camp a variety of types of output mechanisms, writing to consoles, to files, manual copies from visible data sets, ad hoc export from variables. You've seen me click on variables in AnyLogic, press the little graph icon, and see it graph out over time. And those things are very useful for exploratory data analysis. But also important is this whole issue of export to databases. We've done quite a bit of exporting to databases in our time, and I wanted to offer some comments on these. By the way, I provide in these slides here a look at how you can copy data from data sets, copy data from variables, how you can put in charts. We've seen most of that stuff already, but you should realize that it's back here and accessible if you'd like to review these. Because of the time, I'm going to have to go fairly quickly through this. We have talked about export to console. I'm going to come back to the issue of databases, but with respect to console, you should realize there's several options for outputting to console, and if you're going to output quite a bit to the console, you may want to highlight some things by using different colors. So, for example, system.error.println, using that instead of traceln will print things out in a red color. And that may allow ready visibility. It is easy to copy console items elsewhere, but it's of limited length. It depends on your memory to copy it. It's less structured, and it could be mixed in with other output. Data to files, well, we've seen this. We've seen how we can export data to tab-delimited files, to text files. With tab-delimited files, you could simply issue tabs between things into Excel files. This is very powerful. Unfortunately, the data that's exported is not what we call in computer science normalized, meaning that if you have what conceptually are data that belongs to different relationships, you either have to repeat those on each, you either have to have a header information up front of information that doesn't need to be repeated on each row, or you have to repeat it on each row. In either case, the structure of the resulting file is not regular. So suppose you have data on, who ran the model, or when it was run, or the model version. You either have a very regular file which repeats that in each row, or you have that information listed in a header but then parsing it in R or other tools is a little bit more complex. I do show some alternative ways of exporting data here. This is for an earlier version of AnyLogic, but it does show how you could output a tab in a tab delimited format, output a data set in using Java. And you could often place these this sort of data output in events to fire at the final time or in that onDestroy event. The onDestroy handler. Okay, let's talk about output to databases. We've made a heavy use of this. It's more flexible than string output to files. You can easily clean it up. You can wipe out large sets of data that are no longer relevant because you realize they were created with a buggy model or an outdated version of the model. You can query it from diverse tools. You can capture data in a normalized form, so you can capture data without repeating it in separate rows quite readily by putting it in different tables. And for larger databases, you may be concerned about transactionality. If you're inputting data, it should be complete or as if you've not inserted any. You don't want to import or trying to put in data that's cut off halfway through and that is corrupted, as we say. And for larger databases, you might want to support users that can query from multiple machines. And databases can be used for all these reasons. They're very powerful, flexible, scalable tools when you choose the appropriate database for your needs. At a personal level, people often start with something like Access, but Access has very weak support for a lot of important common needs, and those include supporting multiple users and supporting transactionality. If you go up a level from that, there are databases like MySQL or SQL Server for the desktop edition that provide greater support for basic needs. And further up from that, there are things like Postgres and SQL Server and Oracle and DB2, etc. Databases are very powerful mechanisms. You can also query them from diverse other systems. So if you're working in R, you're working at SPSS, you're working in SAS, or what have you, all those will support data interfaces to draw in data from an SQL database. So we found that very effective. The cons of this is there's somewhat more programming. AnyLogic does provide inborn support in its higher versions for SQL databases, and you need to set up a database. You need to define the so-called database schema ahead of time. What data do you want to record? What are the data types associated with it? What are the basic tables? And you may want to have some support from a computer scientist or a database administrator for that purpose, an IT person. So the basic deal here is on a one-time basis, you install the database, you set up the database schema, and you add reference to database libraries. And then for each scenario, you open a database connection, say at the start of the model, you insert into the database information, say in the model version, parameter information, and then periodically you insert data into the database, and then at the end of model execution, you close it. If you're going over a network, this can be fairly time-consuming. If you're going locally, it can still add overhead, but it may be acceptable. And I list a bunch of different types of database of different levels of sophistication. These ones to the left are localized databases that are often quite fast, but are on your computer. And you can see within AnyLogic, there's a region, and Priyasri showed it to you. Her tool works with 7.0.2, but she's getting it working with 7.0.3, and so she showed it to you in 6.9. But in version 7.0.3, which we're going through right here, if you go to the model as a whole and you go to properties for the model, you'll see that there's this jar file, and this allows you to specify these external Java archives. And typically there are such archives for supporting particular databases. and those archives would allow you to connect, say, to a SQL Server database or what have you. So this would be a MySQL database, which is a popular open source database, a popular free database. Yeah.
I notice you don't have SQLite 3 up there.
No, I don't. And I don't know.
Do you have any experiences with that?
We have experiences on using it, I thought, on handheld devices, but I don't on these sort of machines, so I can't speak to it from experience. But I'll put it down there. I've certainly heard of it, and I think it's one of many. There are quite a few others that are left off my list, such as Derby, which probably deserve to be on there, but SQLite, right? And I believe we've just one. Okay. There we go. Maybe worth considering. I'd welcome any input. We've used Access and H2 a lot ourselves. Yeah. Oh, I didn't mean. So I was just saying, if you want to see where those are inserted, they're under the model as a whole. And you scroll down, and you can go to this jar file area. But you probably don't have the requisite jar right on your computer, but you can download jars. You can download this one for free, the MySQL connector, and it will be perfectly fine. Now, AnyLogic Professional and maybe the research version support built-in database classes. We've created our own database classes, and we use them. They're really small, simple. One of my students, Yuan Tian, first created them, and we've used them subsequently and evolved them some. And they're really tiny. I mean, here, you execute a query, you take in an SQL string, which is a structured query language, it's called, to deal with these relational databases, and it goes and it gets a connection, it creates a statement and executes the query, and it returns the so-called record set, which allows you to go through and sort of go through the information returned from the database. And it's really simple. You can set up a variable called MyDB, which is a new of a certain class, and this is most of the class. This is the MyDB class. So basically, you paste this into your model. You create a new class, you paste it in, and then you can make use of it in your actual model. This is an example of some of the code that Yuan was working on at one point. So you insert into the database. This is, I think, a count of people. This is, I'd have to look at what this is. Yeah, I think it's a count of people of a certain age group, ethnicity, health state, and the time, and then the number of people, and then the simulation ID associated with this, which particular run, and she inserts it into a database there. Very powerful mechanism. A couple suggestions. First of all, maintain metadata. Maintain information on the purpose of the run, if possible, a text on what you're trying to get out of this run, because it's hard to remember that context later, on the parameter settings and model versions. But especially be mindful of performance and space burdens. It's very easily to fill up gigabytes and gigabytes, if not these days terabytes of space with output from the models. And it's tempting to think you can have it all and output everything from the model runs dynamically, all the states of agents, and have rich use of that. And chances are it will slow things down very considerably, and you won't be using it later. And we've had cases where we've had, easily tens, hundreds of gigabytes burnt up in databases that we make very little use of retrospectively. Performance concerns can be allayed a little bit by batching up data inserts. So you can do the inserts all at once in a single SQL statement. But the more fundamental issue is be selective in what data to store. I can't give any hard and fast rules of thumb here, but I would say Learn from your experience. It's again the Yagni principle. You ain't going to need it. So until you have strong confidence you're going to need this data for certain types of analyses, don't go speculatively, inserting just massive amounts of data. You'll waste a lot of time putting in place the infrastructure, waste a lot of time because the runs will go slower, and you'll waste a lot of space, and it will just add to the overhead of the modeling process. So I would say go, and as you find needs that prove helpful for your analysis, you can add them in. You can do exploratory recording of certain types of data with a focused goal in mind of evaluating how useful it is. But don't go trying to store massive numbers of statistics or massive amounts of model state over time. So you can really have impaired performance, mammoth database sizes. All the more so if you're going over a network, because you may be congesting the network. And if possible, use a local database that's running on your machine, because that will be going through process boundaries, but it won't be going across network boundaries. And the network boundaries are even slower. Both involve overhead, but networks are even slower. Now, database input can be desirable when feeding data into the model. We also have models which do this, which read in initial population state or characteristics from databases. And this can be very good. At other times, we've basically used database information to choreograph connections being made and broken. And these things can be helpful, and dynamic events can offer some help in this sort of database read-in context by batching things up into time units and then spreading them out over the course, say, of a year, as I spoke earlier. So databases are, in our work, they're central to our investigations. They're very flexible, and like agent-based modeling, whose flexibility recommends it, the flexibility also raises challenges. You really want to be very conscious and incremental in your decision-making for them, and look to your experience before deciding to put everything into the database schema, just like you look to your experience before putting everything into the model. Get experience, learn from your experience, and then reevaluate what needs to be in this model, what needs to be in this database. Same basic principle for some similar reasons. Flexibility sometimes breeds unnecessary mechanism. And I would again advise considering the Yagni principle. Okay, lots more could be said on the output front. We have a quite nice little flexible system that we've evolved, which I'm not going to be able to show you. I have models which demonstrate it, but it basically allows you to fairly declaratively specify things like the flow statistics that you want to compute, and makes it extremely simple to collect the sort of data that we manually went in and inserted those variables to collect earlier today. Priesri is also working, will be working over the next year with AnyLogic, as well as likely Repast as a platform to automate some of this data collection. At a conceptual level, big picture folks here, data collection processes in models, what I call epiphenomenal processes, because they observe the model, but they don't influence the model. They don't change the model. They don't lead to governing processes changing within the model. They're called by Railspec and Grimm observer processes. Often there's a fair bit of mechanism put into those processes, a fair bit of logic you put in your model to collect the right data at the right times. I personally, as a software engineer and as a modeler, feel that specification of the observer model is fairly orthogonal to, fairly distinct from, and should be able to be specified separate from the core model logic. And so we're working towards mechanisms that would allow you to basically mix and match a given underlying model with different lenses that would collect different sorts of data, and allow an end user, not the modeler, but the people elsewhere in the team, to pick the lens they want to use to observe the same basic model. So we're working with aspects, reflection technologies to allow for sort of a more flexible design where instead of having to intermingle the code to collect the data on the model with the model itself, that you could specify both separately and have them woven together automatically, much as the pre-as-release mechanism get woven into a model to collect the right sort of data. So this is the vision we're working towards. It's a fairly articulated vision that we're trying to realize for any logic. We're also trying to realize it for our own agent-based modeling language and ultimately for repast as well. So those are some comments there. Any questions on this front before I go into a different topic? And time is getting really short. Yeah, David.
Specific questions about the comment you made there right at the end.
Sure.
In terms of bringing a different lens.
Yeah.
It's kind of like we might have heterogeneity in our agents or something like that, but we don't know exactly which aspect of that heterogeneity we want to understand.
Right.
Is that the type of thing that you'd be able to analyze, or
yes.
Something different?
Yes. Well, I have a conviction, again, sort of wearing these dual hats as a software engineer, as a modeler. I have a conviction that right now, from working with diverse models to produce the data we need to inform stakeholders' decisions on this data, that the ways in which we describe what data we want to collect are unnecessarily inflexible and cumbersome, unnecessarily burdensome for the modeler, and unnecessarily limiting for the other people in the project team, in the sense that if they want to see a given output, they have to ask me as a modeler to insert it. And moreover, I have to go through my model. We saw it today, right? We have to go through a model and say, you know, count infections main.count infections plus, and we have to, you know, maintain these variables on longitudinal information of agents. The basic gist of what I'm saying is that we have a better way to do it in software engineering, in the sense that we have tools that can look at your model and say, oh, there are these state charts, okay? There are these parameters by which people can differ, these states that they can be in, and there are these variables that they maintain, maybe these stocks and flows, and could offer you a general means of kind of specifying, okay, I want to see this sort of data collected longitudinally on these sorts of people, broken down in these sorts of ways, so that you could specify. Let's take an example of a high-level statistic. I want to specify the median, that's the statistic, on income or age or, you know, earnings or someone's health state, you know, broken down, you know, over these people, broken down in these sort of ways according to population characteristics. And that should be able to be fairly declaratively specified. And it should be able to be specified not at time when you build the model. That shouldn't have to be hardwired into the model, that this is the breakdown we use, full stop. But it should be able to be set by the model user at the time they're running the model. And that's where pre-as-release thesis is going, towards that ability to sort of declaratively specify when you run the model, it will peer inside the model. And that's what our code does now. Our model code peers inside the model and says, oh, you got those state charts, eh? You got those message transitions, eh? You got those, you know, you've got these agents who are in this population, eh? Okay, I will now report on them. It kind of knows about what's inside the model, and we believe we can find tools that will do the same thing and allow you to run the model and pick for that model run whether you want to use a tried and true type of lens you've used before, whether you want to explore in an exploratory way, sort of slice and dice it in different ways or compute other statistics. So the idea would be to separate that out from the model specification, because the model specification is complex enough. Why burden it with having to hardwire in all these things about what data you want to collect when conceptually it's fairly orthogonal to the model spec? It's something which depends on some details of the model spec, but details that we can figure out through reflection. We can figure out, have automated processes sort of figure out what's there and how to collect data. It won't be for everything, but we believe we can get 80% of all needs dealt with in that sort of way. Is that helpful? Totally.
Well, if it's going to take a week to run this, all of these runs again,
right.
I'm going to collect everything I want
right.
up front.
Right.
Everything.
Because
later I don't want to be rerunning that.
Right.
But if you can easily then from those trace file or something recreate anything you want, then you don't have to worry about that you collected the right.
Yeah, and I think the trace files have something to do with that. These sort of general trace files. I also think for models that are cheaper to run, to exploratorily run them, matter of minutes. That could be very powerful to do there, even just getting it to rerun it. It should be able to balance between what data do I have already computed versus, how cheap would it be to sort of run again. So anyway, I think there's promise there. Part of the issue with instrumenting a model to collect data for databases is that it may go from a week to running to 2 weeks to running, but then you don't have to run it 5 more times, right? And so that may still be a win. It's just that from our experiments also, sometimes you don't know ahead of time whether a run is going to be significant. So you make that run, you say, we should have specified this thing. That really wasn't what we want. And so now you go back and you rerun it, and that time it has greater gravity to it, but you don't necessarily know that ahead of time. So I think this whole issue of how much to collect and when to specify that, when to sort of build that in, I think this is something which really needs some further exploration, elucidation. We're hoping the Priya-Sri's thesis, myself and her co-supervisor, Chris Duchin, who was a pioneer in the aspect world, we're hoping that this will be an opportunity to further explore these issues, and I welcome these sort of comments. Okay, great. Time is a ticking, so I'm gonna stop these comments on model